So today we discuss electromagnetic wave. Okay, so the last part of class 12 physics part 1. Okay, the class 12 physics part 1 last part or last chapter electromagnetic wave, and last topic is electromagnetic wave. Okay, okay. So previous class we discussed the Maxwell's equation. Okay, Maxwell equation is the basic fundamental concept of that electromagnetic wave. Okay, the Maxwell equation is the fundamental. Okay, of the fundamental building blocks, or say that is the concept derived from Maxwell's equation. Okay, now this name suggests the electromagnetic wave, the electric field and magnetic field combined together we get electromagnetic wave. And 1887 the Hertz laboratory verified the prediction the Maxwell's equation. Okay, the first detecting in Hertz laboratory in 1887. Okay, so the name is electric and magnetic. So electric field, when a charge, stationary charge produces electric field and moving charge produces a magnetic field. Okay, so and if the charge is accelerating, produce an electromagnetic wave. Okay, so now if a charge is accelerate, okay, suppose there is a harmonically, there is some harmonics, and harmonically accelerate means there is a mean position and there is an acceleration. Okay, if some particle belongs to here and vibrate on vertically, we get some waves here. So waves. Okay, and these are the electromagnetic waves. When a particle vibrate in, suppose in up and down vertically, suppose we get electric field, and vibrate in horizontally, we get some magnetic field here. Okay, these are combined, these two. So suppose we consider, say that is a electric field in x direction. Okay, particle vibrate on x direction. So maximum, that is E naught sine, and the equation is that kz minus omega t. There's a wave. Okay, and this k represents the wave vector. K is wave vector, and that is k, that is equal to 2 pi by lambda. Lambda is the wavelength, okay, on electric field. Okay, and this omega is the angular frequency, that is equal to 2 pi f, that is also said 2 pi by t. T is a time period. Okay, now if I put these together and we get E naught sine k, that is 2 pi by lambda, z omega, that is 2 pi by t times small t. So suppose E naught sine 2 pi common, so z by lambda, and small t by capital T. If 2 pi common, okay, so z direction is the propagation, okay, and particle vibrate or charge vibrate in x direction. Now the graph, okay, very important, the graph is look like this. Okay, suppose x, y and z, and you see that very carefully, the electric field particle vibrate on x direction and propagate in z direction. So propagation. So wave means there is a propagation. These are electric field, not magnetic field. They combine electric and magnetic, we get electromagnetic. Okay, so there's x. Suppose a particle vibrate in x direction. Suppose now waves look like. Okay, now vibration was x direction plus x and minus x. That's the electric field E. Okay. So now what is a magnetic field? These are the electric, and now what is a magnetic field? Similar like electric field. So that is a B if the electric field and magnetic field, they are mutually perpendicular. Okay, and previous class we discussed, we see that here in when we derive that Maxwell's equation, okay, and modified the Ampere's law. Okay, when you see that time the electric and magnetic field, they are mutually perpendicular. So if electric field particle vibrate in an x direction, so the magnetic field due to the charge particle, magnetic charge particle vibrate in that y direction, plus y minus y. So now that is y, and propagate also z direction, and this EM wave propagates in z direction. Suppose now the B not maximum and sine z minus omega t, same, and we get final expression B not sine 2 pi z by lambda minus small t by capital T. Okay, and you see that there is a in phase, both are in phase, no phase difference between electric and magnetic field waves. Okay, both are in same phase. Okay, these are the same phase representation. So this cutting point be the same. Okay, the cutting point, this point be the same, and now this diagram is look like this. Then for due to magnetic field. Okay, and now particle vibrate, magnetic particles. So now that's the B. B in Y, E in X. But they are propagate both are in XZ, and that is a YZ. Both propagate in Z direction. And this representation is that electromagnetic wave. These are electromagnetic wave. Okay. These are the basic building block of the electromagnetic wave. And electromagnetic wave travel in vacuum. Okay, and now if I multiply, okay, if there is c the speed of light, and that is equal to 3 into 10 to the power 8 meter per second. If visible light also electromagnetic wave, so c we know that is equal to root over of mu naught permeability of free space time, permittivity of free space. If I multiply these two, we get this. So visible light also a electromagnetic wave. Okay, keep in mind. Now there are some properties, or there are some wave, okay, properties are structure here. Some electromagnetic wave, and you see that these, and the orderly arrangement of the electromagnetic wave according to their wavelength lambda and frequency, that is the nu c equal to nu lambda. Okay, c is the speed of light. So there are the types of electromagnetic wave. Suppose the radio waves. Okay, the wavelength range is greater than 0.1 meter, and the source is oscillating circuit, AC circuit, and key application where you apply here, there's radio, TV broadcasting, MRI devices. Okay, is a medical instrumentation. Microwaves, the length is 0.1 meter to 0.1 millimeter. Okay, and there's a klystron, magnetron, radar, microwave ovens, mobile phone. Infrared IR radiation, that is 1 millimeter to 700 nanometer. Okay, and suppose the hot bodies, molecules, thermal imaging, remote control, and greenhouse. Visible light, mainly when you see that light, these are 700 nanometer to 400 nanometer, sun, hot object, LEDs. Actually, the key application, human vision, photography, fiber optics, these are the visible light. Ultraviolet 400 nanometer to 1 nanometer, the sun, very hot bodies, arc lamps, sterilizing water, detecting a faults documentation, okay, and vitamin D production when you use that ultraviolet UV radiation. X-ray 1 nanometer to 10 to the minus 3 nanometer, fast electrons striking a metal target for medical diagnostics, okay, for bone imaging and security scanner and X-ray, okay, and as final is gamma ray, that is less than a 10 to the minus 3 nanometer for radioactive nuclear reaction, cancer treatment, radiotherapy. That's a very important. Okay, today is the modern physics, modern medical science. So okay, there's the groundbreaking of the suppose the invention for treatment of cancer. Okay, the studying atomic structure, how to remember these waves, and the mnemonics to remember the order. So mnemonics is a rabbit may infect very unusual xenon garden. So rabbit may infect very unusual xenon garden. So rabbit R, these R is a radio. Again is a may means micro. Next infect means infrared, is a very means visible, unusual, UV radiation, xenon, X-ray, and garden represent the gamma. That's a basic number, okay. And basic property also, the what is the properties of radio waves, and there's basic structure. You see that NCERT books, these all are here, okay. And the different types of electromagnetic waves, there's another table. You get NCERT books. There is a summary how to remember the xenon radiation. Okay, that's a very important. If you remember this, and that's very easy. Okay. Now, some properties of the electromagnetic waves. They are transverse in nature. They travel the speed of light 10 to 10 to the 8 meter per second. Okay, actually you see that here, that is multiply these two, permeability of free space and permittivity of free space, that is C square equal to 1 by reciprocal of mu 0 and epsilon 0. Okay, so that the electric and magnetic field oscillate in a phase, so each their maximum and minimum same time and place. So ratio is the E naught and B naught, that is C, and that is in vacuum. They carry the energy and momentum, so energy density U, that is half epsilon naught E square and half mu 0 B square. There is the energy in electric field and energy in magnetic field. Exact radiation or the pressure on surface prove that carry momentum. They can be polarized, a property of transverse wave, that's why they are the polarized. Okay, these are the you get in board exam and 1 or 2 marks question. What is the property of electromagnetic wave, and as another important, some wavelength range application of that, all types of electromagnetic waves. Okay, from these, and these are the mnemonic of to order to remember. Rabbit may infect very unusual xenon garden. Okay, radio, micro, infrared, visible, UV ray, X-ray, and gamma ray. Okay, that's the basic, and that's the enough for board exam. Okay, so and JEE NEET exam, as I said, actually you can not important, very important in that in JEE NEET exam, but very important for board exam. Okay, so that's why these are the complete structure of part 1. We complete the part 1, and next class we start from part 2. This is optics and modern physics. So today end the class here. If you have any doubt, please ask in comment section. I will try to give the answer. Thank you so much for your time.